Okay, this is question number 4 from unit test 1. And we've had a request specifically to see it done an alternative way. And the in the first method, the video solutions that we did sort of an intuitive method of factoring the x cubed plus 27. So uh, as an alternative, what I'll do is I'll show polynomial long division for this, but there's also a technique called synthetic division that you can use, which really is polynomial long division, um, just looking at the coefficients um, instead of including the variable. So at any rate, we're going to start the same way. We're going to start by factoring this thing and identifying x as a common factor and dividing the x out of each term. Then, to go further, you sort of have to look at this x cubed plus 27 piece, and you have to identify a zero of that thing, right? You would sort of have to see that, or know numerically that your numeracy would have to kick in, and you would have to realize that -3 cubed would result in this term being a zero. And when we say something is a zero, then we're identifying um, a root as if it was set equal to zero, is what we're saying. So if x equals -3 is a zero, and then that tells us by bringing the -3 to the other side, additive inverse, right, that x plus 3 is going to have to be a factor of that thing. So in terms of dividing this thing apart, one of the factors is going to be x plus 3. And then the question becomes, what would be the other factor, right? So if you look at arithmetic for a minute, all right, and you probably don't do this, but um, and say you had 324, all right, and you knew that that was because the sum of the digits is a multiple of 3, then you know that the number is divisible by 3. You know that one of the factors of 324 is 3, right? And suppose it wasn't immediately obvious, then you could do this little thing called long division, and you could say, all right, 3 is a factor, so I set up my long division, and 1 times 3 is 3, and then we subtract, we get 0, and we get a 2, and so there's no 3's in 2, and then you bring down the 4, and then you go, oh, 8, and so 8 times 3 is 24, and there's no remainder. So you know that the other factor is 108, right? So that's how that would work in arithmetic. And you probably do that in elementary school, and so there's that process, okay? Now, if we kick it up to algebra, we're going to basically use the exact same technique. We know one factor of x cubed plus 27. We know one factor is x plus 3. And then the question is, what's the other factor? Well, I'm going to write out the x cubed plus 27, and I'm going to include the x squared term by saying there's 0 x squares in there. And I'm going to say that there's 0 x's in there. And then I'm also going to include, of course, the plus 27. So we're just going to do long division with these expressions and watch how this goes. Well, I want to match up the x to the x cubed, so that means I'm going to need an x squared. And of course, when you do that multiplication, just the same as you do in arithmetic, you get x cubed, we planned it that way, right, plus 3x squared. Okay. Now, then what you do in the arithmetic process is subtract, and we're going to do the same thing in the algebra process. And when we do that subtraction, 0 minus 3 is -3 x squared. And just like we do in the arithmetic process, we bring down the plus 0x. And then we again ask ourselves, what do we have to multiply by up here to match up the negative 3x squared, right? And so we're going to have to multiply by negative 3x. So again, you identify the term here, right? And you ask yourself, okay, x times what is going to give me negative 3x squared? Well, that would be negative 3x. So when you do this multiplication, you get negative 3x squared. There's the match, just the way I planned it. And then you take what you get on the next term, and on the next term, that's minus 9x. Because 3 times minus 3x is minus 9x. Just like you do in arithmetic, you subtract. And of course, negative 3x minus 3x squared, you're going to add. So those are going to go away, and there won't be any x squareds. And 0 minus 9x is 9x. And now we bring down our 27, which is a plus 27. And finally, one last time, we look at what we have down here. We know our divisor is x plus 3, and we question what would we multiply by to create a match on that 9x. And of course, the match would be created by a plus 9. And so 9 times x gives us exactly what we want, the 9x. And as luck would have it, 9 times 3 gives us plus 27. So when we do our subtraction, all right, we do our subtraction, there is no remainder. And so we've determined that this missing factor in here, right, it's no longer a question. We now know that this missing factor is x squared minus 3x plus 9. And then from there, of course, the x is algebraically prime. The x plus 3 is an algebraically prime expression over the integers. And x squared minus 3x plus 9, try to factor that. It won't factor. There's no numbers where you can multiply and get 9 and add and get negative 3. And so you have reached an algebraically prime expression that represents our x to the fourth plus 27x in a fully factored form. So that's an alternative technique to the video technique that we displayed the answers, which was sort of more intuitive, and we'd like your numeracy to get to that level. And also, if you want to check another method, and there's enough of these online, you can look up synthetic division. And there's lots of videos on YouTube about how you do synthetic division. Basically, synthetic division is just polynomial long division where you only look at the coefficients instead of the variables. And it's pretty easy to understand. There's a number of videos out there on it. So there's the answered request for the alternative method for unit test 1 question 4. We hope people found it helpful.